Okay, guys, in this part of the chapter, we want to talk about parallelograms. And so parallelograms, basically, we need to start out with a definition. A parallelogram is a quadrilateral. Let me write this down. A parallelogram. I love the name parallelogram, by the way. Parallelogram. Okay, so parallelogram is a quadrilateral. A quadrilateral where opposite sides are, you can guess, parallel. Okay, so what that means, in our picture we have quadrilateral A, B, C, D. What that means, if this is a parallelogram, that means we have AB is parallel to CD, and BC is parallel to AD. Okay, so that's our definition of a parallelogram. Okay, just a quadrilateral, and the opposing sides are parallel. Okay, so obviously a square would be an example of a parallelogram. So let's move over here. I want to talk about some properties of parallelograms. All right, so parallelograms, I've drawn one here. Basically, there are different properties. Okay, so A, B, C, D. And these are theorems, and I'm just going to briefly talk about them. But basically, these are the properties of parallelograms. Number one, if you have a parallelogram, then are congruent to the opposite sides. So, for example, AB is congruent to CD, and BC is congruent to AD. And the reason that is because if you think about this parallelogram, I'm not going to mark it up because I want to use it for the other properties here. But if we think about this, and I draw a line from B to D, okay, then these triangles, BAD, is going to be congruent to DCB, and so that'll be by SAS. Okay, so by SAS, those triangles will be congruent, so these sides will be congruent. Okay, and similarly, the top and the bottom will be congruent. So that's where that comes from. So again, let me draw parallelogram. And if this is true, if it's a parallelogram, then it's a property that it must, this side and this side are congruent, and this side and this side are congruent. So that's what it looks like in a picture. We'll, of course, go over examples in a little bit in the next video. But the second property is that angle B is congruent to angle D. So opposite angles are congruent, and angle A and angle C. So opposite angles are congruent. All right. So the reason we can do that is sort of the same sort of logic. You can draw a line here, and by using this, then SSS. So these triangles, ACD and, let's see, ACD and CBA, those triangles would be congruent and by SSS. So if those are congruent, then we know that the corresponding angles are congruent. So what that looks like is, okay, we have, if these are parallel, then that implies that these are going to be congruent. Okay? All right. Third property is that these angles, AB and CD, are those sum to 180. They are supplementary. Okay? Those are supplementary. So the way we know this is because of the properties of when a transversal cuts a parallel line. So we know that any interior angles, any consecutive interior angles, when a transversal cuts two parallel lines, then we know that they're supplementary, so we can use that fact. And so what that means, again, we'll go over some examples, but if you have, let's say this is a parallelogram, okay, and if you have this angle is, let's say, 70, well, then you can figure out every other angle. You know that if that's 70, that must be 110. You know if that's 110 because of property 2, that this is 110, and you know by property 2 that this is also 70. So that's how you can sort of work those out. Finally, if angle A, or if any angle in a parallelogram, so these are all talking about quadrilaterals, if you have a quadrilateral ABCD, if any angle is 90 degrees, all four angles are 90 degrees. So again, this follows kind of from the properties 2 and 3. Okay, so if one of these is 90, well, if you know that parallelogram here. All right, so we have the given is parallelogram. Okay, so if we have a parallelogram and one is 90, okay, well, we know that by property 3 that this must also be 90 because it must be supplementary, and we know that the opposite angle must be by property 2, we know that the opposite angle must be congruent, and we know that the opposite angle of this angle must also be congruent to that, so that's 90. So anyway, if one angle is 90, then all the angles are 90. So these four properties. Okay, let me summarize again. If you have a parallelogram, so the given must be if it's parallel. Okay, so this doesn't apply to every quadrilateral, but if the two sides are parallel, then opposite sides are congruent, opposite angles are congruent, angles on the same side add to 180, and so it's not just AB and CD. Let me add here. It's also AD, so angle A plus angle D equals 180. Okay, and also B and C, angle B and angle C equals 180. Okay, so just to be clear, so those angles add up to 180, and if one angle is 90, then all of them are 90. So we'll do some examples in the next video, but this was just a little bit of an introduction about what a parallelogram is and its properties. Thanks for watching.